Today's lesson is lesson 6.5. We're going to be covering the linear inequalities. You've been graphing linear equations for a while. This is just when you can have more than one point solve the inequality, because it doesn't have to be equal to, it could be less or greater, depending on the sign. The first thing you're going to do is check to see if a point is a solution. So you'll take this x, y, and plug it in for x and y, and see if it makes a true statement. So this one would be 2 is greater than 1 minus 3. Plugging in 1 for x, 2 for y. 2 is greater than negative 2. Notice how I brought it down to one number on each side. One number here and here on each side. That's how you know you're done. Don't stop early, even though you can do that math in your head. And then if it's true that 2 really is greater than negative 2, you would say that yes, this is a solution. Meaning, if I were to graph this equation, inequality, that point right there would be shaded. That's what it means if it's a solution. All right, now I want you guys to plug in x and y, and then we'll check your work here in just a second. Pause the video. Your answer should be that it would not be shaded because negative 7 is not greater than negative 6. So if you were looking at a graph that was an inequality, and you had a line there and a shading, what you just found out is that this point would be on the unshaded part of the line. This point would be on the shaded. This seems to be sort of backwards of what I just did here, but just like that's what I mean by shaded and unshaded. All right, now I want you to pause the video and plug in 3 for x and plug in 6 for y. I might have shown a step in my work that you didn't show. I took 2 times 3 and 3 times 1 and got 6 over 3. Some people might have jumped directly to the 2, and that's fine too, it doesn't matter. You get to the end and you get to a statement that sometimes confuses people. If I said that 6 is less than or equal to, 6 is less or equal to 6. That's what I would say out loud. Well, it might not be less, but it is indeed equal. So that makes this a true statement. So this would be in the shaded region. This would be a yes. This would be a solution. Okay? All right, we're going to graph and do some of the shading that goes with that graphing now. A couple of things that you're going to want to keep in mind when you are graphing slope-intercept. When you are graphing slope-intercept, it's really easy to tell which way to shade because you just look and see if y is greater or y is greater than or equal to, you shade above the line or the higher part of y. If you have y is less or y is less than or equal to, you shade below the line or the lower portion of y. The next thing that you're going to want to keep in mind is that if you have symbols that look like this, you use a dashed line. If you have symbols that look like this, you use a solid line. There's 2 pieces of information that are going to be helpful to you as you make your graph. So when I go here to graph this one, I know that this is the y-intercept, meaning 0, 1. This is my slope, meaning the change in y is 1, while the change in x is 2. So I start by plotting 0, 1, go up 1 over 2. This symbol does not have the equal bar under it. It's one of these. So I would have to make a dashed line when I draw it. So I hold my ruler down and just make a few dashed marks along that line. And then here it's saying that y is greater, which means if I'm looking at this y-axis, if I focus in on the y-axis, I want to shade, in comparison to my line, I want to shade all the stuff that is the greater part of y and go right up to your line, like that. So this would have been the lower part of y. This is the greater part, or above the line. The other way to tell which way to shade is to plug in a point. So you can always look at your line and say, well, my line's sitting here. I could pick a point above or pick a point below and see if it works. The easiest point to ever use is 0, 0. So you could look at here and you could check your shading by plugging in 0 and saying, is 0 really greater than 1? 0 really is not bigger than 1, which tells me that the point 0, 0 is not shaded. And that makes sense. I did graph in the right direction. So if you have trouble determining ever what is the higher part of y or the lower part of y, or this statement, these two statements somehow are not making sense to you given the way your line looks, plug in 0, 0 and check it that way instead. All right, turn the page. This is a standard form equation, so we're going to want to find the x and y intercepts. So we're going to do that work where we cover up x and say 3y is equal to 15, divide, and we get that y is 5. We're going to cover up y and say 5x is equal to 15, divide by 5, and get x is 3. You'll notice I used equal signs when I was doing this work here. That was intentional. These equal signs are for the points that I use to plot the graph. So I'm just looking to see where should I plot on x, where should I plot on y, so it is equal in this case. If I have found what y is, it means I plot a point at 0, 5. If I found, pardon me, if I find what x is, I would plot a 3, 0. These are my x and y intercepts. So I'm going to go over here and plot the point 3, 0 and the point 0, 5. And I'm going to look and see, should I be drawing a solid or a dashed line? This symbol has that equal sign part to it, meaning my line should be solid. You're not going to want to use pen and markers and stuff like that when you do homework like this, because it can get real messy real quick. People drawing a solid line and then making an arrow to it and saying, this is really dashed. It gets hard for me to correct, and sometimes I just honestly can't tell what you mean, and I end up marking it wrong. I'm not trying to be a jerk, but it can get tough. When I'm working with a standard form equation, I don't look and go, y is less. Any kind of negative sign being thrown in there can kind of confuse the matter a little bit. So I don't trust y is less, so shade below. This is all plus sign, so it'll probably be accurate, but I don't ever trust it. So what I do is I check my shading by plugging in the point that is easiest to work with, 0, 0. If 0 fits and it makes a true sentence, I'll shade that side where 0 is. If 0 does not fit and it is untrue, I'll shade not where 0 is. I'll shade that side. So I'm going to say 5 times 0 plus 3 times 0. Is that really less than 15? In other words, is 0 really smaller than 15? And it's true, so that means that 0, 0 should get shaded. Now, I don't typically write all this when I'm doing my homework or my answer keys. This I do in my head, but I'm showing it to you because it's your notes. You're going to need to see it. So then when I'm thinking of my shading, I just said that 0, 0 is a solution. So if I picture my line is here, I want to shade where 0 is. I don't want to shade there because that would cover 0. Or I mean, this would cover 0. It should look like that. If I shade here, then 0, 0 would not be shaded at all. And this is telling me 0, 0 should be. So then I shade in this direction. We're going to talk about that just a little bit more here. We're going to first recall what HOI-VUX was. Remember that acronym that we use? A horizontal line has a slope of 0, and it is a y equals equation. So y equals a number. A vertical line has an undefined slope, and it is an x equals a number type equation. So HOI and VUX. When I am looking at this problem, I have y, meaning I could write the word HOI with it. I should have a horizontal line. It looks like the horizon. The O, the slope of 0, is like the sun coming up over it, like a horizon. This is a slope of 0. So I plot the point 0, negative 4, and then draw my horizontal line. This is dashed because it does not have that equal underneath it. So I dash this line. And then this is telling me that y is greater. So if I look at this as my y-axis, the greater numbers are up here. That's where I should be shading. Let's say you want to plug in a point to check it. Well, you only have one number in your point. So you'd say, is 0 really bigger than -4? Is 0 really bigger than -4? And it's true, it is. So notice how 0 is part of the shaded. I'm going to pause the video, and I want you, or you're going to pause it, and I want you to do that problem. All right, your graph should look something like this. It's saying that x is less than or equal to. So if x is less, I'm shading the numbers on this x-axis that really are smaller than 3. It's true that 0 is less than or equal to 3. That's why 0 is shaded. I used a vertical line because it would make the phrase vox, hoi, vox, plotted at 3, and used a solid line because it had that equal symbol there. Anything sitting on the point is a solution. Anything sitting on the point here would not be. If I were to name this point, I would be saying that -4 is greater than -4, and it wouldn't work. The dashed line represents things that are not solutions. The solid line represents anything touching it is a solution. Let's take a look at these ones. I feel like if you're taking the MCAs, you're more likely to see questions like this, where it'll be a pre-made graph, and it's your job to write the equation for it. When you're given a graph, you're always going to write a slope-intercept equation. We don't try to write standard form from a graph, really. So the first thing you want to do is look for your y-intercept. So here's your y-axis, touches at -3, so I'll say -3. You're going to pick any 2 points along your line to find the rise and run between them, because remember, slope is change in y over change in x. The only 2 points I can really identify are the 2 that you see here, kind of on the x and y axis. Up 1, 2, 3 over 2. So my slope is +3 over +2x. Now I'm going to ditch this equal sign here, and now I'm going to start thinking about what this should be. Notice how it is the higher y values. In other words, greater. The greater part of y has been shaded. So y is greater. This is a dashed line, so it won't get the equal. All right, with that in mind, I want you to pause the video and see if you can write the equation for the one right there. Now on this one, I chose these 2 points, so it went down 3 and over 1, so that's why I had a slope of -3. It touches at +3 on the axis, so I used +3. I used a solid line, or the graph is a solid line, so I used the equal sign here. Notice it's the shading is on the greater numbers of y, like greater for y is the higher numbers, so I made y greater. All right, let's turn the page. Word problems in this section can be slope-intercept or standard form. We see a lot of standard form opportunities here, so it makes it easier to graph. You plot where x is, plot where y is. You can see all of the solutions, so usually it's standard form. You can see everything then. So we're going to write an ax plus by equals c. If you're wondering how you know that just from reading, remember, if they give you language, and I'll read this one with you. It says a market charge is $9 per pound for cod, $12 per pound for flounder. It says that the number of pounds of cod is going to be x, the number of pounds of flounder is going to be y. What is an inequality that shows how much of each type of fish you get? And then it says you have a daily quota of 120. Anytime you are given a max or a minimum, you know that you're using a greater than less than symbol. Typically, this one says at least 120. So when I make my symbol, I'm going to say like that, 120 is on the lesser side of that sign. Okay? So that is like a total. That's how I know that it is standard form. These two both sound like they're rates or slopes, 12 each, 9 each. Normally that's like mx, but in a standard form equation, you're given your total and your two what sound like rates. So we'll have 9x plus 12y is greater than or equal to 120. Remember that an at least symbol kind of messes with your head. It gives you a greater than sign. Okay. To graph this, we need to find our x and our y intercept. So I cover up y and say 9x equals 120. Equal sign again because it's just a point we're plotting. Cover up x, 12y equals 120. Divide by 12, and we get y is 10. We divide by 9. That one isn't going to come out nice and neat, so I'm going to grab my calculator just so I don't make a silly mistake. And we get 13 1/3, or 13.3. Now, because I'm trying to graph an intercept right now, I will do exactly what this sign tells me to and make my number be greater. So 13.3, I would use 14 for my number then. And I would use the intercept that is greater, because I want my information to show a number that is bigger than 120. If I round down, I run the risk of it not being bigger than 120. You could use 13.5 too, because then it's close. And I think we're talking about pounds, so you could almost get away with, if you can graph it, use 13.3. It isn't going to hurt anything. I've just always done it that way. So my x-axis is pounds of cod. I'm going to have you label and number your axis. I'm going to pause the video while we do that. So I have the cod on the x-axis, flounder on the y-axis. My y-intercept is 10. My x-intercept is 13.5, 13, 14. I like to use the symbol to tell me to round up, so I go up to 14. But again, you can have pounds be non-integers, so you could have plotted about 13.3. Just make sure that your information here is clear. What did you do? What did you think was best? This has an equal bar. Anytime the words at least or at most are used, those indicate equality. They can be equal to it. And you'll draw your line in. When it comes time to shade, you're going to pick a point and say, should I shade above this line or should I shade below this line? So you pick a point and you plug it in. So the easiest point to pick, is 0, 0. So I plug in 9 times 0 plus 12 times 0. And is that really going to be greater than 120? Well, it doesn't make sense that it would. 0 plus 0 is definitely not bigger than 120. So that means that this part of the line shouldn't be shaded. So again, thinking of my line, if this is my shading, this would keep 0 unshaded. 0 is not. This is no, meaning not shaded. So I should shade this way so that 0 is not part of the shading. Sometimes it'll ask you to name right here. It says it, what are 3 possible solutions? And you can pick any points that are shaded and name them. If the line is solid, you can actually pick points on the line too. So like 6, 6 right here is pretty decent. So I could say 6, 6, 10, 6. And if you want to, you could say like 14, 0, because that's on the line too. Those are all possible solutions. They are shaded, or if the line is solid, sitting on the line. Right, your homework will be up on the board. Go ahead and get started. It is due tomorrow. This has to be a one-day lesson. Most of it is review for you anyway, so I'm not too worried about it, but you'll still have to get all that work done for tomorrow. So make sure you're working, use your time well.